Hello there, welcome to lecture 6. Today we will understand the concept of, say, scope of a variable and lifetime of a variable. So as we know that our C program has different segments. If you recall the earlier lecture, so the segment here is data, which is global initialized, and uninitialized will be stored on BSS, block storage start. And then all local data, which is nothing but function and block, will be stored on stack. Now in this case, data can be global, in that global includes static as well. So any data that is dynamically allocated using CLoc or MLoc will be stored on heap. So we knew about it. So if at all we want to find out what is the current size of all these segments, so let us first save this code and compile this code. gcc -o output 1.c. So if I do the output, there is nothing it is able to display because I have not done anything in the code. So there is this command called size, which is going to give us the size of two segments, that is the global segments, size output.exe. So if you note it down, now we have 4344 as text size and data size is 940 plus block storage start is another 96. So we have 5330 is the decimal count of all of this, and this is the hexadecimal count of this. So what we will do is we will now declare a variable called a. So we know this is our global uninitialized. And then if I say bint b equal to 10, this is our global initialized. So let us see what will happen. So I have told you that all uninitialized will go to the block storage start and all initialized will go to the global block. So if you compile this code, so we have the earlier, before modification, this is the data that we have. So let me again run the size command. If you see now, since the size of an integer is 4 bytes, 4 bytes is added to the global data section, and then another 4 bytes is allocated to BSS block storage start because A is uninitialized. This is how it actually does. Suppose if you have say an array, for example, of 5 elements, and you initialize that to say 1 2 3 4 5. So where this should go? This should go to the global initialize segment. So if you compile this, that is because I have initialized A once again. I'll do this A1. Okay, so if you look at this and that code now, right? So since I have initialized 5 integers, so 5 into 4 is 20. 20 bytes have been allocated to this 944 plus 20 bytes, which is 964. Suppose if I have say int A of 5 and say 5000, if this is the dimension of the array that I have, means I have 25,000 elements. So 25,000 elements which is uninitialized should go to the block storage structure. So 25,000 into 4 bytes should be roughly a lakh bytes. Okay, around lakh bytes, so around 1 MB. So let us see. Okay, so if you see here, did I save this code? Let me save this code, compile this code. Oh, that's again because I'll make this as A2 now. Sorry about that. So if you just remember this is 964 and 100. So okay, did I save this? I will save this. Yeah, no problem. So size of output, you see this is what it is. So it was 100, now I have added 1 lakh, almost 1 lakh 208 bytes, because this is global uninitialized. Okay, suppose if I have, for example, if I take all these 3 down and make it as local variables. Okay, so this is my local variables. As we know, all the local variables are stored on the stack. See, now it has come back to our normal thing, wherein it only has allocated global uninitialized A, remaining everything is on the stack. So size will not show you the stack, because the stack grows automatically whenever the function is called. So we also have to look at something called static, include static as well. For example, in this, suppose if I make I know this is a local variable, so I'll make this as static int, okay, which will also be stored on block storage start, but the access to A2 will be through main. Okay, so it is not visible outside main. So let us see how this gets compiled. So we will compile this. So if you remember, that is 940 100. So I do this and I do this. Okay, wonderful. So did we save this by any chance? Let me save this code. Okay, see, now it gets added, right? So even if it is a local variable static, it's get added to block storage start, because I have not initialized this to anything. All right, so hence all the static variables, whether they are declared inside a function or outside a function, for example, let me say static int z equal to 900. Okay, we'll see the meaning of static and all that later. We also, I think we saw it in lecture 4, right? So if you do this and get the output of this, see, this static gets added to the initialize global data section. Okay, so this is what is all about the allocation of the memory variables, okay, in a particular file. All right, next in the subsequent lectures. Hope you understood it. Thank you very much.